Welcome back. In this video, we are in week 11, and we're going to take a look at databases and information systems as the textbook presents it. I have not previewed this PowerPoint presentation. I'm kind of doing the PowerPoint presentations this semester because it's nice, right? And I like to do that every couple of semesters just to see how the book is presenting stuff, and also just have some fresh lectures for students about what they're going over each week in the textbook. So we're going to explain what a database is and why databases are useful. Let's do it. So databases store data. They're the base, right, where data is stored. So a base, like a military base, is where military stuff is stored. A database is a base where data is stored. So that data could be anything. You know, the classic example is like a Facebook post. So you enter some information. What does Facebook do with that? Where do they store it? They put it in a database. And that's what a database is. It stores tons of information, videos, text, all that stuff. And databases are useful because there's a lot of information in the world. And more information now is stored than ever. It's crazy. Back when I was young, when I was a kid, if we wanted to learn something, look something up, we'd have to go to the library, we'd have to find a book, right? That book may or may not exist. We'd look at magazine articles. You had to go ask the librarian to retrieve newspapers, look at microfiche pictures of newspaper on film. It took time. It was not efficient. It was not very effective. You wouldn't find the specific information. Now it's like, you're wondering if, I Googled this the other day. I have one of these when I exercise, a strap, right? And it's a heart monitor, and it's this deal. It's the Polar H10, okay? And so I use this when I exercise because I'm an older dude in my 40s. And I want to make sure that I'm really intense. And I want to make sure, in some things, I want to make sure I don't go over, like push myself too hard and blow out my heart. And so, when I was younger, I didn't think about that. But now I'm like, look, I want to operate to 80 to 95% of my max heart range. Because if you look at max heart rate by age, max heart rate chart, that's what I want. If you look at these max heart rate charts, images, looks like a good one. So you can see here, down here, you have your age, right? And so I'm somewhere in here. And health improvement zone, fitness zone, performance zone, high performance zone. And so for my age, like 170 is like, as max as I should. Well, yeah, 170 is the max of what I should push my heart, they say, right? Over here is the no-go zone. So they say don't go to 180, don't go to 190, don't go to 200 or 210. Like in that zone, I don't know, physical therapist, cardiologist, they say that could maybe blow out your heart and you could have a heart attack, like too much, too hard. So you have to kind of build your body up, right? And you got to work hard, but not too hard. And so when I work out, I want to be able to watch my heart. And so I've got, an exercise bike, and I watch my heart. Anyhow, I wanted to know if, when I was done with this thing, if I needed to take the monitor off the strap. And they said, yes, you do, because otherwise your sweat will cause corrosion over time. And I was like, okay, cool. So that's a really specific question. And I just Google it, and bam, the answer is there. That's amazing. Like in the past, to find that information, to find this chart, like I wouldn't have this at home. I'd have to go to the library. I'd have to talk to a librarian, and then find some articles or find a book. And then it was just laborious and awful. Well, different. But you didn't have the information to make decisions like you do now. It's amazing. You want to find a good restaurant, and there's reviews, or a good anything, you just read through what other people said. And if it's like totally sucky, people have said that. And you're like, okay, I'm not doing that. So it's pretty amazing. So that's what databases are, and this is why they're useful. They give us a lot of information. Okay? And it's storing a lot of data about all kinds of things. The features of a flat database, a relational database, an object-oriented database, multidimensional database. We'll see if there's pictures of those. Web 2.0 data is managed in a database. Describe how relational databases organize and define data. Let's look at relational databases. So I think I have a picture of this. Textbook and PowerPoint, emails, lectures. That's it. Do I have it in here? Okay, here it is. Databases diagram. So can I zoom in on that? Come on, get big for me. So here's a question for you. Here's a puzzle. Which was the first customer to rent American Beauty? Pause the video, figure it out. All right, so here's how this works. We have 3 tables here, and when you store information in a database, you want to group like information into tables. What that means is anything about customers is going to be in the customers table. So first name, last name, address, phone number, that'll all be in the customers table, right? We're not going to put in the customers table, the make of, all the cars in the world. That would be in a different table, information about cars. Customers table is everything about customers. Likewise, movies table will be everything about movies. And, you take that database class that I showed you in the previous video on SQL, you'll learn all about this. And so the movies table will store everything in the movies, and then rentals will store who rented which movie. And so here's 3 tables: customers, rentals, movies. Each table has a unique ID, right? So this 1, 2, 3, 4, 5, 6 under CID is customer ID. It's a unique ID. So just like you have a unique ID with the United States government, if you're a U.S. citizen, like your social security number, that uniquely identifies you. So when you pay your taxes, they know who those taxes are coming from. And so that's what a unique ID serves, right? And so in a database, each record has a unique ID in the table. And so what we could do here is in rentals, instead of storing, the customer name or whatever, we just store the customer's identifier, unique identifier. And so for this rental transaction, and even rentals has a unique ID for each rental transaction. For rental transaction 1, customer with ID 5, Minnie, rented movie with ID 2, which is American Beauty. So Minnie was the first person to rent American Beauty. We know she was the first person because we're making the assumption that these rental ID transactions are going up in increasing order, right? That's the way it kind of looks like it's working. So that's how a relational database works. And if you understand that, you understand relational data. You understand databases more than the vast majority of people. All right. Describe how data is input and managed in a database. Explain what data warehouses are and data marts and how they're used. Describe data mining and how it works. And describe the main types of business information systems, how they're used by business managers. Cool. So a database is a collection of related data that can be stored, sorted, organized, and queried. So queried is how you say ask a question of a database. And I guess this word comes from England, where you can ask a query. Like you could get in a queue, which is a line. So in England, they have slightly different words than in America. So in England, you might get in a queue, which is another way of saying get in a line. And then when you got to the front of the line, you might have a query, right? Which would be a question. You might have a question, you might have a query. So when you query a database, you're asking a question of it. The database advantages are as they manage large amounts of data efficiently. They enable sharing of that information. They promote data integrity. So integrity is a great word. And integrity means something that when you ask something a question, you could rely upon the answer. So if we look up integrity, the quality of being honest and having strong moral principles, moral uprightness, the state of being whole and undivided, right? That's integrity. And so, honest, reliable data integrity is data that you could rely upon, right? And it's you could trust it. So databases promote data integrity, and they do that by when you enter information into a database, there could be constraints which say for the zip code you have to enter like numbers, you can't enter letters. Or when you're choosing your state, you got to choose from a list. So you can't, mistype in the name of the state. I used to work at this place called the Real Estate Land Use Institute in Fresno. And then we would do analysis on real estate transactions. And to do that, we used data from multiple listing services. And the data, sometimes realtors would say, oh, I sold a house in Fresno, but they'd spell it Fernos. And it'd be like totally misspelled. And so if you said, show me all the homes that were sold in Fresno, and you spell it right, that home would get left out because the realtor had misspelled it. They had fumbly fingers when they typed it in. And so that didn't have good data validation, right? And so you could build systems where the data is validated when it's inputted, and then you have better data integrity. So if you ask the system how many houses were sold, it will report the correct number, right? And it won't misreport because of some typo, some typing error. It'll give you the right number. So they promote data integrity. Data integrity ensures databases data is accurate and reliable. Cool. Go to the next slide. Flat databases are represented as a list or a simple table. A flat database problems, data redundancy, data inconsistency, inappropriate data, incomplete data. So, that would be like an Excel spreadsheet would be an example of a flat database. You've got columns and you've got rows, and, it's not as effective as a relational database because you'll have data redundancy. You got to enter the customer's name over and over. You don't just enter it once in the customer's table and then every time they have a transaction, associate the unique ID with the customer with that transaction. For each transaction, you got to enter all the customer's information again. So that results in redundancy and inconsistent data, incomplete data, inappropriate data. So that's a flat database. It's like a simple table. So here's an example of a flat database. You can see data redundancy there with the Garza name. How they enter that information many times. It's like a spreadsheet, right? And data inconsistency, different data on different lists, right? So they updated stuff in one area but not in another one. You can see intro to psych and intro to psychology are typed differently. So that's a flat database. A relational database is the one we looked at where you kind of saw the relationship between customers, rentals, and movies. So you're relating information in different tables, right? It's relational. And that's all we're going to say about that, really. That's all you need to know about that right now. And here's how you can kind of look at a relational database and Access. And so Access, you're learning about this in Access. And you'll see that in your assignments in Canvas and MyLab IT. An object-oriented database stores objects rather than tables. And so, it could store binary large objects, so like videos or pictures, right? So database for storing videos, things like that. Multidimensional database stores data can be analyzed from different dimensions. And relational database is only two dimensions, fields, right, and records. So the records are the rows. The fields are, which piece of information you're capturing for each row. So first name, last name, address, city. And this would be customer 1, customer 2, customer 3, customer 4. So it has fields and rows. But that's two dimensions. But a multidimensional database is like, oh, what if we have, instead of just an XY axis, also a Z axis over time? So just another concept for databases. Nothing to stress or sweat about right now. Main thing you want to take away is flat databases suck. They're like a spreadsheet. They're good for very limited things, but you really want to kind of move into a relational database. That's the main type of database. And then these other ones are things you'll learn about if you really get high-end into storing stuff at a big company. Customize, provide information process data much faster than relational. Nosql database, which is also called, spacing on the name right now, Nosql, which is also called schemaless. It's a schemaless database. Schemaless database is like a relational database, but there's no rules saying you have to relate stuff. So there's no constraints. No constraints put into place. No schemas are required. And so basically it's kind of like the training wheels have been taken off the database. And if you could do what you want, and if you mess it up, it's on you. And so that's schemaless, and it gives you more flexibility, and they could scale better, meaning they could be more available faster to large amounts of people all around the world. And you could query them more quickly. But they also have some data latency, like microseconds for updating in all their locations. Anyhow, there's details about it. But NoSQL schemaless databases, let's see what it says, have been developed to handle newer types of unstructured data. It's unstructured, schemaless. You could add that structure in if you want as a developer. And it stores and manages data so that data can be accessed quickly, and do not provide the same level of data consistency as SQL databases. Well, as a developer, it's your responsibility to make sure that consistency is built in. The database management software, DBMS, is software that allows the computer to perform database functions, and allows you to kind of build and work with your database and relational databases. So access can be seen as a DBMS. It's an interface that allows you to work with a database. And so storing and defining data. Fields are categories of data. So student ID, last name, first name, address, those are fields. And then records are groups of related fields. So there's the first record, there's the next record, there's the next record, right? Those are the rows. And tables are groups of records. Tables are groups of records. So I kind of sometimes talk about this as a database hierarchy. And so a database is made up of tables. Tables are made up of records. Records are made up of fields, and fields are made up of characters of the alphabet. So a database is made up of tables. Tables are made up of records. Like here, this table, student information, is made up of these 1, 2, 3, 4, 5 records. Each record is made up of fields, right? So this is made up of the ID field, the last name field, the first name field, the address field, and each field is made up of characters, alphanumeric characters, right? So letters of the alphabet and numbers, right? So database, tables. Database is made up of tables. Tables are made up of records. Records are made up of fields. Fields are made up of characters. And so that's the database hierarchy. Data types indicate what kind of data is stored in the field. Yeah, so when you create a field, you could say, hey, only text can be stored in this field. Only numbers can be stored in this field. And the computer's going to generate the numbers. It's going to be auto-generated. So, right, you could have your data have better integrity by putting constraints on it. And, you could say what kind of data type is stored in a certain field. And properties, you could set properties of the field, like the field can only be 2 characters long. And that's a constraint that helps maintain the integrity of your data. And so here's access, like zip code, and the field size constraint, it can only be 5. And it gives you a caption. And then you can set a default value too if you wanted. So those are constraints to help ensure data integrity. So the primary key, foreign key, using keys. So when we looked at this image, did I close it? When we looked at this image, these keys are known, these unique identifiers are known as primary keys, right? They're primary to making this whole relational database work. It's the key to making it work. So it's the primary key. So those are primary keys. And when you use them in another database, it's a foreign key. So here, this is a primary key in the customer's database. And over here, it's a foreign key. It's a key from another table where it was the primary key. So that's primary key versus foreign key. And you want to maintain referential integrity. So if I said, hey, customer ID 7 rented this movie, there's no customer ID 7. I'd be like, oh, there's no integrity to that reference. And so you could set your database to always have referential integrity, to never allow those types of references to occur. That's kind of cool. Just scrolling down here. Come on, baby. There we go. Input forms control how new data is entered, so you create forms where data is entered. And data validation ensures that only valid data is entered into a field, right? So you can check a range, like age can never be greater than 110, or whatever you want to say. Whatever. Consistency checks, completeness checks, alphanumeric checks, has to be alphabet, has to be number, those kinds of things. That's how you maintain data integrity. Viewing and sorting data allows you to display and reorder data. Yeah, so you could sort data, query data, you could filter data. Only show me stuff from California, only show me stuff from last year, from this zip code. You could filter all that. And when you output data, you could print it, you could send it to a report, all kinds of ways of outputting data. And then we have data warehouses. So data warehouse is just, it's where data, like we've got so much data, we don't know what to do with it. And this is older data, it goes into a data warehouse. And if we ever need to query stuff that isn't like being used frequently all the time, it could go into a data warehouse. So it's just a large storage area for data that's less frequently accessed as the data warehouse. Large scale collection of data contains and organizes data in one place. Data comes from multiple databases, consolidates information from various systems, presents enterprise-wide view of operations, organized by subject. Okay. Skip that. Data Mart, small slices of data warehouse used to analyze related set of data grouped together and separated out from the main body of data. Compared to a data warehouse, Data Mart information pertains to a single business component. Okay. Data mining. Data mining is like trying to find relationships. So one relationship might be that whenever people buy beer, they often buy pretzels. Oh, so let's put the pretzels near the beer in the grocery store, right? Like if we look through all the data of who's buying what, we might start to see how can we organize the food in our grocery store to help make things efficient for the customer and also to increase sales. Like if people buy beer like pretzels and then the pretzels are right there, they're more likely to pick up a bag of pretzels. And so other data mining might be, like how do we know where's the best place to put a new Starbucks? And what are the, let's look at all the data and figure out what are the things of the Starbucks that are really successful within 2 miles. What's the neighborhood like? Let's look in all that data, and then we could start to figure out where other Starbucks should go. So businesses mine data to make decisions about what they should do. And a lot of that is now getting done with machine learning and artificial intelligence. Techniques, anomaly detection, association or affinity grouping, classification, clustering, estimation, whatever. So data mining techniques. Info system, software-based solution to gather. Let's see what we got here. Yeah, so an information system, this is kind of a new topic. We're moving on from databases now. And an information system is any system designed to provide information. So software-based solution to gather and analyze information, acquire data, process data into information, store the data, and provide output. And so here you can see people doing different stuff. We're gathering information, processing procedures, storing that, and then getting that out, right? And producing reports and giving information to people. So an information system could be like registering at Fresno City College and, when you registered, how long were you in line for? What did you have to do? How did the forms get processed? Where did the data get stored? And then somebody might come in and look at that system and say, how can we improve this system? Right? How can we gather that information more quickly? How can we make it a better experience for people? How can we store it more effectively? How can we use that information more effectively? So how do we make that information system work better? And so when you work when you work, you run into places where information systems are working amazing. You're like, wow, that really works great. And then other times you run into places where, oh, that's not working. Like just today I was interfacing with a company and it was just like wacky. The person I was talking to, she's like, okay, you ordered this, but then that happened. And okay, if I do this, and then if I deduct it from here and your new order, okay. Like she had to do all this finagling to kind of like process my return and make sure I was charged the right amount of money. And it's just like, oh, they have a really broken information system on the back end. And then likewise, there's times where there's information systems that work really well. And so like searching for Google reviews on businesses, it's like, wow, look at all these reviews, amazing. The most amazing thing I saw recently is looking at a business and they could show you right now, they could tell you like, oh, most people spend 45 minutes to an hour on this store. And normally there's this many people in the store at this time, but today there's only that many people in the store. Right now there's just this many people. It's like, wow, right? Like, the power of that, like gathering so much information in real time. And then also other information, reviews and storing, it's amazing. And then we have transaction processing system. So TPS is how we track transactions, like everyday transactions in a business. The classic TPS, transaction processing system, is like a checkout counter where food is being checked out. It's processing transactions or whatever you're buying is being checked out. And then there's different software that could tie into all the information that businesses develop, like management information system is a piece of software that ties into all that data, produces information for managers. Decision support system helps make decisions, right? So it looks at all the information, helps people decide what to do. So maybe looking at weather patterns and making machine learning algorithms, predictions. So here's a really interesting DSS idea. But if you could, like with Powerball and baseball, like how do you put together the best team? Who do you need to hire for the strengths to complement each other? Like that'd be interesting DSS for people who are putting together baseball teams or any type of team, right? That'd be interesting. So there's all kinds of different information systems. And then business intelligence is the ability to improve business decision making. So understanding what your business does and being able to use that data to make better decisions. Enterprise resource planning system accumulates info related to running a business, makes information available to decision makers. All these are kind of just like buzzwords, right? It's just software that helps people do things better. Knowledge-based system, artificial intelligence, fuzzy logic, natural language processing systems, provides intelligence that supplements users' intellect. Yeah, so more buzzwords. Artificial intelligence and machine learning is really pretty amazing. And so you can go to YouTube, understanding machine learning, and kind of look for something on that, or look at for artificial intelligence. YouTube, what is artificial intelligence? And just see what kind of videos you come up with. There's great explanations out there, some amazing stuff. My people, that was week 11. It's good to be back. Tomorrow I'll record week 12. And the day after that I'll do 13. And then I'll be a few days ahead. So I'm getting caught up. And good to see you. Colloquially speaking, I don't see you, but I'm glad that we are connecting in this way again. Even if this is, video, it brings me pleasure, happiness, and delight to know that you are forwarding your skill set, that you are forwarding your education, that you're showing up, that you're doing the work, that you're watching these videos, that some of the stuff I say is just me droning on, but then there's moments, right, where you get something and you're sticking it out through that droning on stuff, which doesn't totally, resonate with you, which we're just kind of covering territory, going over a few things, but then you're getting those gems, those jewels, right, where you understand something. So I commend you for sticking it out to this video. That's amazing. That's great. You're doing an amazing job. So keep it up, and I will see you in week 12.